Hello, everybody. Welcome. Thank you so much for joining us today. We're excited to tell you about a new heat electrification tool that's available to the industry. My name is Julie Brown, and I lead sustainability here at the Outdoor Industry Association. We'll do a quick introduction and then get started. I'm going to go to the next slide. Quick reminder with antitrust guidelines, they are in effect, so please refrain from divulging any confidential or proprietary information, such as non-public cost or volume or strategic information. At the Outdoor Industry Association, we have two programs within our sustainability department, and that is the Climate Action Corps and the Clean Chemistry and Materials Coalition. In the Clean Chemistry and Materials Coalition, members in this group really try to blaze the trail in the innovation and adoption of safer chemicals that still deliver the functional, durable, and trustworthy materials that your customers expect. In the Climate Action Corps, members commit to taking bold collective action against climate change by reducing and removing greenhouse gas emissions across the outdoor industry and really trying to carve a path for other industries to follow. Members do this by committing to collaboratively developing solutions and implementing them within their organizations and throughout their value chains. Next slide. OIA tries to help facilitate this by providing resources such as comprehensive guidebooks to help you follow the Climate Action Corps climate pathway, for example, from all the way from emissions measurement to sharing progress. We provide trainings like virtual events with topical experts to engage and instruct members on addressing different impacts. And we provide collaboration opportunities such as CoLabs aimed at specific impact reduction initiatives and task force where members really roll up their sleeves and discuss innovative solutions with their colleagues. The focus of today's webinar is one of our impact CoLabs. So these CoLabs are collaborative and pre-competitive. Members are working together to reduce emissions, so they're focused on real impact. And the idea is that if companies are working on something together, they can pool together resources for less time and less cost to achieve that impact. Our CoLabs generally focus around things like renewable energy, electrification, efficient manufacturing, and supplier decarbonization. We're very happy to have speakers today that you see here. We have Kim Drenner from Patagonia, Ali Hasanbeigi and Cecilia Springer from Global Efficiency Intelligence, and John Stokes from New Balance. So with that, I am going to pass it over to Kim.
Thanks, Julie. Good morning, good afternoon, good evening, everyone, from where you're joining us today. I'm really excited to get to kind of kick things off. But first, I want to provide just a little bit of a background on the evolution of this Clean Heat CoLab that we at Patagonia and a number of other brands have been working on for a number of years now. In 2021, Patagonia introduced an opportunity to the OIA around trying to find a solution for heating-based emissions in our textile mills. Interested in really trying to understand what those solutions could be. And so we brought forward this funding opportunity and raised some additional funding with some other members. And we were able to kick off formally the first CoLab in 2022 or 2022 around trying to do that industry research. Took about a year, published the study in 2023 around electrification of heating in the textile industry, focused on key geographies within our shared supply chain, specifically Japan, China, and Taiwan. Had a number of webinars with our suppliers and had really great feedback from our suppliers around just the results of that study. And there was this eagerness to want to learn more, really wanting to have something more tangible to help drive decisions in their mills. And that then evolved into the second Clean Heat CoLab that we're here to talk about today around the development of a tool that mills could put in their data and then kind of do some scenario planning on what is that right technology to electrify those heat-based emissions. So here we are at 2025, now publishing this electrification toolkit. So super excited about all of this. it's been a lot of hard work over the years. Next slide, please. Thank you. So this slide just summarizes, it's a nod to all of the brands who kind of came together through the OIA to help fund the work. Brands like REI and Gore and New Balance were there from the very beginning, helping fund this original study. And then we raised some additional funding, bringing in brands like Cotopaxi and LL Bean to help, or not LL Bean, yes, LL Bean, yeah, Cotopaxi and LL Bean to help fund the second study. So none of this could have happened without the collaboration and the support of all these brands listed here today, and as well as the support and facilitation of the OIA. So with that, I will pass this over to Ali at Global Efficiency Intelligence Group to give you an overview of the tool.
Thank you, Kim. Well, good morning, everyone, or good afternoon. I know a lot of folks joining from Europe as well. I'm Ali Hasanbeigi. I'm the CEO and Research Director at Global Efficiency Intelligence. Maybe a quick introduction about us. We are a consulting firm based in the US. We do a lot of research on industrial decarbonization across different industries and across different countries. Textile industry is one of the sectors we have done a fair amount of work on. Fun fact, actually, I have textile engineering background myself. I did undergrad and master's degree in textile technology engineering. And then from the PhD program, I decided to kind of expand to other sectors as well. But having the textile engineering background over the years, have done a fair amount of work on textile industry decarbonization, including the work we have done recently, which we're going to talk about. I have with me also my colleague Cecilia Springer, who will introduce herself shortly. Before I start, I would like to thank all the brands who supported this work: Patagonia, New Balance, REI, Cotopaxi, Gore, and LL Bean, and also OIA. This is a great example of collaborative effort. Like when we did this first CoLab study, the report that is shown here, and we were talking about it with Kim 2021, Patagonia actually kind of was thinking to, or we were talking to ask Patagonia to kind of fund it, but they wanted to do it collaboratively, and that was a great idea. So I'd like to thank Kim and Patagonia to bring us to OIA and starting this collaborative effort for the study, as well as the tool that we are releasing today. So the previous report that we published about 2 years ago or so was to look at electrification of heating in textile industry, which is basically a big challenge when we talk about deep decarbonization of the textile industry. The electricity part, you can do the renewable electricity procurement in some of the countries is now actually available, but the heat is the main challenge. So a lot of people were talking about deep decarbonization, but they were not actually mentioning much about electrification. And we had done a lot of studies for other sectors. So we did this study covering China, Japan, and Taiwan as case studies, and also covering major electrification technology, steam boilers, electric steam boilers, electric thermal oil boilers, and also heat pumps, as well as direct electrification of processes. Next slide, please. We published that report already, and it's available from our website. You don't need to try to read these figures. I know they're a bit small, but the key finding is actually electrification offers a great opportunity for the textile industry for decarbonization. If you electrify the heating, meaning your steam generation or other heat demands, and also then tie that electrification to renewable electricity supply, which more and more is available in more geographies. In China, in India, corporate RE procurement is now fairly readily accessible in many regions. Therefore, you can actually deep decarbonize even today or in near future. So and all the technologies are available today. And when you electrify automatically, because electricity is high-grade energy, you reduce an energy use. You're talking about comparing, for example, a conventional steam boiler with 70 to 80% efficiency versus electric steam boiler, which is 99% efficient, versus a steam generating heat pump, which can be 200% plus efficient with a COP of 2 to 2.5. That's why in our report, you will see great reduction in energy use and significant reduction in CO2 reduction over time, depending on your electricity supply. You can read the report for much, much greater detail on that study. Next slide, please. We received significant amount of interest after we published the report. We can claim that with the support of OIA and the brand, we put electrification of heating on the map in the conversations. If you read even the roadmaps that were published before, they were not talking much about electrification. And now actually is the center of the conversation as the real solution for deep decarbonization, moving towards net zero in textile industry. Because of the interest that we receive and all the follow-up projects that we have been doing with some of the brands that are here today and some other brands, we have been working with their suppliers in Asia, Thailand, Vietnam, India, Sri Lanka, China. We have been doing plant-level feasibility analysis for electrification of heating in textile plants. So we thought to kind of democratize this knowledge, and we are not able to do so many of this feasibility study because we have hundreds and thousands of textile plants all over the world. So we decided to create this tool to allow people anywhere in the world, any engineer, any manager in textile and apparel industry, to be able to do the feasibility or pre-feasibility analysis for electrification of heating in textile plants or facilities. And the tool covers all major technologies that you would want when you do the analysis, which is electric steam boiler, electric thermal oil boiler, and steam generating industrial heat pump. And all these technologies are available today. They are commercial. We are not talking about some futuristic technology. You can buy them today. In the tool, actually, we provide a list of suppliers in different countries. There are some myths out there, for example, electric boilers are not suitable for industrial application. That's totally not correct. And even a steam generating heat pump, there are suppliers that they would provide the technology to you today. And we are in touch with them. Actually, we have connected, for example, industrial heat pump suppliers to textile manufacturing plants in Asia. And they're having that conversation to implement this technology down the road. Next slide, please. So the tool includes these technologies and then does what I would call techno-economic analysis. You put the information in the tool, some input data, and Cecilia is going to show you in more detail shortly. And then the tool will provide the results in terms of what would be the energy impact, emissions impact, cost analysis. It's an Excel-based tool. We tried our best to make it as user-friendly as possible. And it can be used by anyone, anywhere in the world. And to make it easier, we put some default data. Of course, we did extensive research to provide default data, for example, with regards to the price of different types of energy, the emission factor of the electricity, etc., and some of the forecasts for some of the major textile producing countries, 10 of them: Bangladesh, China, India, Indonesia, Japan, Mexico, etc., Vietnam. But any other country, they can use the tool. It just, the default values are not there. You have to put your own data, which fortunately, textile facilities, they are the ones who have the data. So should not be an issue. Next slide, please. So we kicked the tool development in December 2023. We have been following different steps for developing the tool. And along the way, we had quarterly sessions with the brands who supported it and quite intense discussion and consultation, presenting the beta version of the tool and the following versions. And also we did some testing of the earlier version of the tool, both with the brands and their suppliers in Asia. We got the feedback, we refined the tool, and today we are releasing the final version of the tool, which is available in English, in Chinese, in Vietnamese, in the Spanish and Thai language. Both the tools and all the instructions in it are in all these 5 languages available. Next slide, please. So some very brief, again, Cecilia will give you very detailed demo of the tool, but the tool is designed for facilities, textile facilities anywhere in the world to put their data, get their plant-specific analysis done and plant-specific results shown. And we also try to automate some insight based on your result to give you some kind of next step action plans, which is in the tool, and Cecilia will show you. In addition to that, as I mentioned, the tool does the analysis for steam technologies, steam boilers, steam generating heat pump, but also for thermal oil boilers. As you know, in wet processing plant, thermal oil account for anything between 30 to 50% of fuel use. We also have built-in manufacturers databases for electric boilers, for industrial heat pumps in different countries. You will see that. And also we have provided action plan based on some of the results that the analysis provide in the tool. Next slide, please. Okay, that was kind of a high-level overview of what we have done and how the tool was developed. And now my colleague Cecilia Springer will show a demo of the tool, that how you could actually use the tool and what kind of result it could generate. Cecilia?
Great, thanks, Ali. My name is Cecilia Springer. I'm a principal at Global Efficiency Intelligence, and I'm very excited to go through a demo of the tool with everybody today. And so I think my screen looks good. Hopefully everybody can see it.
Yep, looks good, Cecilia.
Great, thank you. So as Ali mentioned, this is a downloadable tool that anybody can use. So once you open this tool, you'll see the cover page, and I'm going to take you through all of the functions of the tool, and we'll actually use some example data and see what the tool can do. So the first thing that you'll want to do, as with anything, is to read the instructions. So throughout the tool, you'll see green buttons, and clicking on them will advance you to the next part of the tool and the next functionality of the tool. So the instructions show the menu of all of the different sheets that the tool has, which will open one by one as you click through. So as Ali mentioned, we have a place for users to put in their input data, and then there will be two options, a quick or a detailed assessment, and I'll show you that. Similarly, there will be a summary of results and then more detailed results. And the tool also has an implementation action plan for users who want to think about next steps for electrification. And then there are also databases for manufacturers and suppliers of the technologies evaluated, namely electric boilers and heat pumps. An important thing to note about the tool is that it requires macros. And so on the web page where you download the tool, as well as here in the tool, we provide some instructions and troubleshooting if you're having some issues with macros. But overall, we try to make it as usable as possible, point and click to get through the tool. So I'll start with just a very brief overview of the methodology. I think Ali already mentioned our, some of the metrics that we looked at in the previous study and that we've also adapted and added on for this tool. But we're evaluating two different electrification technologies for steam generation, either heat pumps or electric steam boilers, and then one electrification technology for thermal oil-based heating, which are electric thermal oil boilers. And we talk in this tab a little bit more about how we looked at the energy and CO2 emissions and the costs. I also just want to highlight that we wanted to present users with two scenarios for their electricity source. So one is a user-specified baseline grid plus renewable energy procurement scenario where the electrifying facility uses grid electricity plus a share of renewable electricity directly procured, for example, through power purchase agreements, and the user can specify their level and what their targets might be in this scenario. And we also wanted users to be able to compare this to a scenario where they're able to procure 100% of their electricity from renewable energy sources from 2030 onwards. So throughout the tool, you'll see results for this baseline and ambitious renewable energy procurement scenarios. And those differ in their associated emissions as well as their costs, because in our default data that we've gathered for different countries, we're seeing that in many cases, procured renewable electricity can actually be lower cost for facilities than grid electricity. So that's a quick overview of how we develop the tool, and users can definitely come back and read this in more detail, but let's get started. So in the Start Here tab, you'll be able to select the country or region where your facility that you're evaluating is located. And there are 10, as Ali mentioned, there are 10 different countries where we've collected extensive default data that will help you with the analysis, and which can, of course, be fine-tuned by the user. There's also an option for other. We've covered a lot of the largest textile manufacturing countries, but of course, not all of the countries. So if you select other, it'll just require a little bit more input data to generate results. And then you can either select a quick assessment or the detailed assessment. So I'll show you both of these, but for now, let's look at the quick assessment. And for now, let's say we're looking at a facility in China. So throughout the tool, you'll see yellow boxes where users can specify input data. And the tool needs a little bit of input data to run, of course. You'll need to provide some information on fuel usage in the facility based on the current conventional boilers being used. And then you'll also need to put in the annual production levels for facilities in terms of kilograms of finished fabric. And with just those two data points, the tool will pull in default data and specifications about a typical textile facility to generate results. But of course, the more that users can provide, the more accurate and realistic the results will be. So you'll see the default data in blue. For example, here we have industrial electricity prices and projections for the grid in China, and much more default data. So for now, I will put in some example data. Let's say that we're looking at a facility in China that's using coal for steam-based heating and for thermal oil boilers. And let's say, again, this is example data that they're producing about 13,000 tons per year of finished fabric. So this tool will look at a base year, which the user can specify or use our default year of 2023. And then we're looking at what will the effects of electrification be over the next 15 years. So we'll look at 2030, 2035, and 2040 to see what the impacts could be, because this is the lifetimes of the technologies that were evaluated. Before I generate results, I just want to show you what the more detailed input data tab looks like. So if you want to add more information, you will be able to provide a lot more detail, for example, on the quality of the fuel used, its emissions factor, detailed fuel prices, for several different kinds of fuels that are typically used in boilers. There are also CapEx and OpEx inputs. We provide estimated investment costs per unit of capacity for the electrification technologies, as well as their operating costs. And then we also provide inputs on the technical characteristics of the conventional boilers, their efficiency, and some other variables. I just want to highlight as an example here, let's say you expect in China that domestic manufacturing of heat pumps is going to take off in the next few years, and that you think capital costs might come down. So you, for example, you could come in here and say, actually, I think investments costs are going to be a little bit lower over the timeline of this study. You can also specify the setup of boilers in the facility, the number of boilers and their capacity, and this will help provide more accurate CapEx calculations. Another important variable is also the availability of waste heat, which is important for the heat pump systems that could be installed. So you can also go in and specify the average temperature of wastewater discharged from what processes, and this will affect the efficiency of the modeled heat pumps. So this is our more detailed tab. Again, user data can be specified in yellow and the defaults can be seen in blue. And then there's one more input data tab that I want to show you. Again, we have extensive default data based on the prior study and our research at GEI. And this is information on the textile production process for the facility of interest. And here, even though there are other ways to electrify, we're focusing on steam and thermal oil for process heating. So if any of these steps you are using direct fire, for example, then we're not including them in the analysis. So users can put in what percentage of their fabrics are undergoing each step, the heat supply, as I mentioned, temperatures and steam requirements. And then we also left an area where users can define their own processes for more specialty production processes. As long as you put in the associated information, then this will be factored in. So let's go ahead and check the results. So you can click Generate Results. You can click Generate Results as early as in the Quick Input Data tab, but I just wanted to show you some of the more detailed inputs that can be used. So let's generate results. This is our results summary page, where we try to present key takeaways. The first type of result that we go through are the annual energy savings from electrification. So if you'll remember, here are the example data is for a facility that's using coal, and it could electrify with either electric steam boilers or heat pumps. So here for the steam technologies, we compare them against the annual energy demand of the conventional steam boilers. And as Ali mentioned, electrification will lead to large gains in efficiency. And you can see that's much more the case for the heat pumps, but even with electric boilers, you'll get efficiency gains. And we also show results for the thermal oil boilers. The next type of results that we are looking at are the annual CO2 emissions reductions, and results in the summary are presented as percent decreases relative to the base year. And so it's important to note we have this, written as well as visualized. And here you can see the two different scenarios, the baseline grid plus renewable energy procurement, and then ambitious renewable energy procurement with 100% renewable energy. So if you're using 100% renewable energy, you'll also have zero emissions associated with the heating. And then it's also important to note in some countries, the grid is very carbon intensive due to using a lot of coal to generate electric power. And so there are some cases where electrification with boilers could increase emissions unless you're procuring more renewable energy. And so in those cases, the tool will give you a little note in red here that there could be emissions increases in the near term with certain technologies if you're not procuring a certain amount of renewable electricity. And the great thing about the tool is that you can go in and play with it and see exactly how much renewable electricity you might need if your goal is to reduce emissions. And then we also have our results related to costs. We look at energy costs and in what year the electrification technology will lead to cost reductions. We know here we're using default data for China. Costs for energy all come down to the electricity to fuel price ratio. And so based on our default data, there could be near-term energy cost increases when switching to electricity, which is for now more expensive than coal. And so the tool will also highlight when energy costs will come down, and then what's going to be happening in the near term if energy costs will be higher. And then under the ambitious scenario with more renewable energy procurement, you'll, with the default data here, you'll generally see more favorable results because of the ability to procure relatively lower cost renewable electricity. We then show results on the estimated CapEx to meet the heating demand at that facility for these different technologies. And we also present results on the levelized cost of heating. The levelized cost of heating is a very important metric, we think, for evaluating these technologies based on costs over their lifetime. We know that, over the technology lifetime, there are going to be changes in fuel costs, in electricity costs, potentially in carbon pricing in some of these countries. And so we created this levelized cost metric to look at, the present value of the lifetime CapEx, OpEx, energy, and carbon costs. And so we show this in table form as well as graph form. And in this case, with the example data in China, you can see that heat pumps actually have the lowest levelized cost of heating over technology at lifetime, driven by their very, very high efficiency, which will save on energy costs over the life of the technology. We also present an analysis of simple payback period, knowing that this is a very important decision-making tool for many. We think it's a relatively simplified metric compared to levelized cost, but we do say what the payback period would be based on installation. And you can see, while some technologies have a lower levelized cost compared to conventional technologies, they're not necessarily generating payback. And so we think that's why it's important to present both of these metrics. For users who want to get more into details, we have 2 tabs with detailed results on the steam technologies, the electric steam boilers, and the heat pumps. And we also have detailed results on the thermal oil boilers. And I think in the interest of time, I won't go through these in super detail, but just to show that these will show the numerical results by year for these different metrics that we're looking at: the energy, the CO2 emissions, the costs, and then some of those financials. We also look at additional electric load from electrification. This will, of course, necessarily be adding to the demand from the grid or from renewable electricity procurement. So that's an additional result that we present here. So detailed results for steam technologies and thermal oil boilers. And from there, we direct users to an implementation action plan for users who are interested in next steps. So we have an infographic plus some more detailed information about what would happen next. We talk about the pre-feasibility steps on data gathering, what you would need to do to work with technology suppliers and plan for electrical load increase, and then securing financing, which is a very important part of the process. And we make recommendations on what facilities could do, and then some guidance on implementation as well as monitoring performance over time. And then lastly, for users who are interested in those next steps, we have 2 databases, an electric boiler manufacturer and supplier database where we provide company names, their websites, and information, as well as some technical information about the characteristics of the technologies they can provide. And likewise, an industrial heat pump manufacturer and supplier database. And to the extent possible, we've provided some descriptions of their heat pump specifications and applications that these suppliers and manufacturers can provide. And with that, I'll turn it to see if Ali has any additional comments on the tool demo, and then we'll move on to the next speaker.
Sounds good. Thank you, Cecilia. That was a great demo. Nothing much, just I see some questions. Because of the time constraint, we cannot get into too much detail. Like some of the terminologies, what is baseline grid plus REA, ambitious grid, CapEx, they are provided in the methodology. We have instruction section, methodology section. So we really tried our best to make it as user-friendly as possible. So so don't worry if you are not following, and you see the tool provide quite a bit of detailed analysis. Hopefully that will be the strength. as much as possible, if the user provide their own data and input, the tool will give more a specific result to tailor to your plant. So you can put a few data points, do the quick assessment, get a sense of how the economics of these technologies are. But if you do the detailed assessment, provide more detailed input for your plants as much as you can with regards to cost, with regards to emissions, characteristic of the fuel you are going to use, the forecast of the cost in your own plant and country or region, then the result will be, of course, more tailored towards your plant. So that's just a quick note on using the tool. Otherwise, I think that the demo said the rest. We can, I guess, turn it back to John or Breana. John, I think next is you.
Yep. Yeah. Just real quick. Thank you both, and thanks everyone for joining today. Special thanks, of course, to Patagonia and OIA for bringing the CoLab project together. I'm John Stokes, Director of Sustainability at New Balance. We're very pleased to have been part of this work all along, and really hope this tool becomes a valuable resource as we try to tackle clean thermal energy as an industry. So, New Balance has an SBT, I suspect, like many of you, that requires significant reductions in Scope 3 emissions. And of course, the energy used in process heating across our supply chain, particularly textile mills, represents a big opportunity for decarbonization. We've been working closely with our suppliers for many years on energy efficiency and creating renewable energy transition plans. And I'd say, most of that focus in prior years has primarily been on the sort of supplier Scope 2 side of things. And I think we're now getting to a point where it's maturing. The conversation's really developing around Scope 1 emissions opportunities, and it's exciting to see the potential for electrification as part of that. The tool is new, exciting to see it out there, and we're ramping up to make this tool part of our overall climate program as we work with suppliers in the pursuit of clean heat solutions. So the application, I think, is pretty clear. I think, we're still finalizing our deployment strategy for 2025 and beyond, to be honest. Initially, we'll start using this with our strategic suppliers, narrowing down where electrification may make the most sense, informing a more specific action plan, both on our side and on the supplier side. And I think overall, the intent there is to inform a more educated approach, get some early wins, and really allow us and our suppliers to deploy resources kind of most efficiently. Really good opportunities, especially in the beginning. So Ali mentioned some specific site assessments that had been done. We were one of those brands working with GEI at a couple of our supplier sites in Indonesia. Some really good results coming out of that. And I see this tool as a really perfect application kind of prior to those, so that we can understand the landscape a bit more and then target those really more in-depth assessments and implementation planning where they make the most sense, and even understand which technologies might be most applicable or most attractive at a particular site versus another. So that's really our intent on getting started with the tool. Super excited to get it going. I'd say in addition to that type of work, policy engagement has been a really big part of our climate program as a brand. And I think output from this tool could easily become part of that effort as well, kind of informing our advocacy efforts, particularly in markets where electrification feasibility may fall short for one reason or another. I think having quantifiable results of potential reduction and identifying what those key barriers are can really educate and bolster our policy asks. So that's another opportunity, I think, for taking lessons from this tool, taking the output and really feeding it into another sort of key part of our climate action planning. So, those are just some initial thoughts on how we're looking at the tool and planning to roll it out. Any other brands that were part of this, if you're on and want to jump in, please do. I think otherwise, I'll hand it back to Breana for some Q&A. So thank you very much.
Thanks, John. Hi, Ali. And I was just leaving space for if any of the other brands wanted to come on to share their experience, or we can dive into Q&A. Okay, great. Well, let's dive into Q&A. We have a couple questions already, and if folks have questions for us, feel free to type them in the Q&A, and we'll do our best to get through as many as we can. We have a good amount of time. So starting with you mentioned at the beginning of the presentation that moving heat generation to electricity can help reduce a facility's carbon intensity. So as long as they're sourcing from a renewable electrical source, how do you recommend researching and developing renewable electrical sources with factories given the high amount that's required to power a facility? More in your research, in our research, we found that factories rely on purchased electricity have very high carbon intensity because the local grid is very dirty. Ellie, maybe that's for you.
Yeah, maybe I can start. So good question. So we talk about electrification. We need electricity. Of course, we want it clean. First thing, you do not need zero carbon electricity in order to electrify. Actually, depending on technology, if you use, for example, heat pump, you can have a fairly dirty electricity and still have lower CO2 emission for your steam generation compared to coal. So you can have fairly high carbon intensive electricity, use it industrial heat pump, a steam generating heat pump, and produce steam, and still you emit less than coal-fired boilers. Of course, we want the electricity to eventually get cleaner and to move towards zero. But don't think that you need zero carbon electricity now. In some of the countries, for example, in India, in China, the corporate RE procurement like PPA, power purchase agreement, other mechanisms, they're really moving in the right direction. Today, corporates, they do megawatt scale. I mean, steel plants are doing PPA in India now, and in China also. I mean, textile plants, the amount of power demand you need compared to what's happening is really small. And by the way, the tool will tell you how much exactly megawatt you need if you electrify your plant. So in some of the geographies, it's very promising. It can happen today based on what we are seeing in terms of the supply of RE. In some of the geographies, let's say Bangladesh, Indonesia, it's more challenging. Hopefully, in the coming years, they will get the corporate RE procurement market in place. So the power supply in terms of RE will at least be resolved, like what we have now in India and many parts of China. The financing piece of the technology, of course, the additional costs, whether it's CapEx, OpEx, is a whole different conversation. I don't get into that because it was not the question. But the RE supply piece, in some geographies, we can electrify today fairly easily.
Awesome. Thanks, Ellie. We are getting some questions too about the link for the tool and slides and recording. So yes, all of those things will be available. We'll have a follow-up email that has the recording, so you'll be able to see Cecilia's demo, and we'll share the slides, of course, as well. And that link, or we'll also include a link to the tool, and we'll send that in just a second here once we're done with Q&A. So another question is, does the tool also integrate the NDC targets for countries that have an impact on grid emission intensity in 2030?
Maybe I can start on that one. Yes, for the 10 countries that have default data, we use their NDCs, which as of right now, all 10 countries except for Bangladesh and Mexico have an NDC. And we use that year. We assume that they do achieve their goal of zero carbon economy and electricity by then. And we use that to project grid decarbonization over time. So that's why you'll see in 2030, grid emissions factors are still high in some countries, but 2040, they are a bit lower. And then, of course, the more renewable electricity that you integrate, that will also offset grid emissions factors. So yes, that is taken into account. But of course, users can also specify what they think the trajectory might be.
Great. Thanks, Cecilia. Another one. I'm trying to go through kind of the technical questions of the tool first. So where balanced and continuous steam demand is not applicable and peak demand is required, how does the tool account for multiple heat sources?
So in the tool, the tool is designed so the user can input their data. I saw another question with regards to fuel type, whether you want to put coal, biomass, natural gas, fuel oil. We know different countries, different type of fuel. So you can put that and then compare that versus the electric technologies. So you will see the techno-economics of it. And then you can also have potentially, like, for example, you have like 2, 3 boilers, which is quite common. And you say, okay, for one of them, I want to electrify or go electric. So you put your data maybe for that one boiler and see if you electrify that one boiler, whether using electric boiler or heat pump. So these are some of the decisions that the user can make. And based on that, use the capability of the tool to get insight. I hope that answered the question. Cecilia, anything you want to add?
Great. We also had a question if it's possible to translate the tool into a different language. We have some of the other resources translated, but a question if we can translate the tool itself.
Yeah, the tool is translated currently into 4 languages, so plus English. So we are going to have it, it's already on the website in Chinese, Vietnamese, Spanish, and Thai, which covers quite a lot of languages. Yes, we can translate into additional languages based on the demand, and hopefully we can get some support from the brands. Yes, we can do that.
Great. Then we have a question that's asking more about the process of developing the tool. So the question was asking about a redesign of the tool now that we've beta tested it. But if Ali or Cecilia, you want to speak to how we did integrate the feedback from the beta testing, as well as there's another part of the question, what is the additional benefit factor that this brings that was not part of the original? Oh, what are users loving about it that was not predicted?
Cecilia, do you want to?
That's a good question. Yeah, I think one thing that was really helpful in the beta testing was seeing how users thought about some of the cost and financial metrics. So first, when testing it with the brands, we got the idea that we should have a results summary and maybe something that presents results in percentage change rather than just the numbers, like emissions will be X% lower in 2030 relative to 2023 levels if you electrify. And I think that's how some of brands' emissions reductions targets are formulated. And so we added some of that kind of summary and different ways of presenting the results. And then in the beta testing, more with like textile manufacturers and suppliers, we found that there is interest in having a little bit more on the financial metrics. So having levelized cost of heating for the steam and thermal oil technologies for different kinds of boilers. And then also having simple payback. And so we also tried to distinguish between these financial metrics and show how you can maybe not have simple payback, but have a lower lifetime cost. And so we tried to make that clear in the tools and results.
Great.
That's good.
Thanks, Cecilia. We have a question about accounting for maintenance costs. Can you talk about how that is incorporated?
Yes, so we do take into account operation and maintenance costs in the tool, and these are factored into the levelized cost of heating or the lifetime cost. And so you'll see that in the levelized cost chart, there's a little bar for OPEX, but the full name would be operation and maintenance costs. And users can also specify what they think those would be per unit of heating, and we have default values.
Great. How does the tool factor in IREX into the electricity mix?
I don't think
Uh,
we are using IREX. Carbon price can be a factor. Cecilia, maybe you can talk about the carbon price.
Yeah, we do model or have the capability to include a carbon price in the tool. I didn't talk about that because of lack of time, but a lot of these countries are currently implementing or considering implementing carbon pricing. For example, China has an emissions trading system that is expanding its sectoral coverage and could potentially include the textile industry in the future. It certainly includes the electric power industry already. Then there's also the consideration of carbon border adjustment type policies that would essentially be an external carbon tax for countries that are exporting textiles. So for users who are considering that, or maybe a company that has an internal carbon price, a brand that wants to look at that, we included the option for looking at carbon pricing. But as for IREX, we use the term renewable energy procurement in our electricity scenarios, but we're sort of agnostic about exactly how that is procured. So we mentioned power purchase agreements, but if users believe that IREX can deliver zero carbon electricity, then that's all factored into procurement of renewable electricity. We don't say exactly what kind that is. This is more the techno-economic side of the evaluation.
Great, thanks, Cecilia. And going back to levelized costs, we have a question there. So are the costs associated with an electrical service upgrade considered in the metrics like levelized cost and simple payback?
Yeah, I saw there were a couple questions about that. So yes, in the levelized cost, we compare the lifetime cost of a new coal boiler, a new natural gas boiler, and then the electric boilers and the heat pumps. And so for the electrified technologies, we do consider our estimates of what the additional costs would be for electrical upgrades and additional equipment to be adding all of that electrical load. And so that is added to the electrified technologies, but not to the conventional technologies like coal and natural gas.
Great, thanks, Cecilia. And this might be a question for Kim and John. Would love your commentary here, but is there any example or plan from brands to incentivize suppliers to adopt the tool and technology?
Yeah, maybe I can start, and if John wants to jump in, feel free. So we work very closely with our suppliers. We fund a lot of studies, energy audits, feasibility studies, and this is just one more thing that we're bringing forward to our supply chain. Not really pressuring them to go out and to have to fund this work, and so we really see through our partnership that there's a lot of incentives that we're helping them on this journey. There's a lot of pressure our suppliers are getting from brands to decarbonize, first with the coal phase out, and then coming and saying just electrify. And so we're trying to show up with those solutions and really support them along that journey. Some brands are divesting from suppliers, so there, I think, are incentives. Suppliers are trying to look at all their options, and this provides more kind of tangible solutions in terms of really what are the financials, the cost. And so that's really the starting point for us to understand, like, what is the cost burden? How can we potentially financially support a supplier in implementing this technology? And so that's where I see this tool being extremely helpful in facilitating those kind of starting conversations about we're really serious about working in partnership on decarbonization with you. Let's understand what your solutions are and what the costs are, and then how can we both move forward together.
Yeah, I'll just add, it's obviously like a really good question, and I think a lot of developments in this space specific to different brands in terms of how they're engaging with suppliers and funding or co-funding things, or have various ways to do that. One other consideration, like at New Balance, another way that we also look at like the incentive side of things is like we're starting to build metrics like their renewable energy use and or maybe some sort of like innovation metric into supplier scorecards. And these are scorecards that are owned by the sourcing team that have like an allocation for these things. And that then becomes part of the conversation directly between sourcing and suppliers. And so we're sort of building it into the conversation that we're having with them, and automatically making it not a requirement, but like it's an easy way for them to sort of demonstrate another advantage to working with them.
Thanks, Kim and John. And our group too has been talking about potentially continuing the collaboration and using the tool at facilities where they share the suppliers. So that's in conversation. And as that develops, we'll keep folks in the loop should you want to get involved. Looks like this discussion has people thinking about supplier experience. So what has the supplier experience been using the tool? Any examples or testimonies that we can share? So if Kim, John, you want to share anything about the beta testing you did, that'd be great.
Maybe I can jump in and Kim there.
Who wants to go first?
So I think, as we mentioned, we did several rounds of testing with the brands, and then we had two beta testing sessions. One was for sort of Asia-based time zone, and one was for more like North America-based time zones. And we got a lot of really great questions. I think there was a lot of interest in how to most effectively use the tool. And so I think that's why, we'll have this recording and the demo, and Ali and I are always available for, troubleshooting and so on. And as I mentioned earlier, there was a lot of interest in, refining some of the metrics in the way that was presented. As for testimonials, I don't know if I'm like allowed to share, the direct, conversations from those meetings, but I think we're hoping to see people use this and then let us know how it goes. Those were just demo sessions. So now it's out there in the world, and we'll be very keen to hear feedback, continue to refine and improve based on what we see.
Yeah.
One thing. Go ahead.
Go ahead, Ali.
Just one thing to quickly add, from all the interaction we have had with especially suppliers, they are really keen to learn about electrification. I mean, if you go to talk to suppliers, they know, like literally, I was talking to folks in India, they're like, we know everything about biomass and the problem with it and the technology. It's been around for a decade. But you'll be surprised how many people simply don't know the basics of electrification technology. It just, hasn't been the conversation. And then we coming, providing information, providing the tool, allowing them to do fairly sophisticated analysis, by the way. If you hire us to do this analysis, we charge quite a bit. That's what we charge in New Balance. So it's a positive feedback we got in terms of the novelty of this topic. And the need for people to come and provide the information about the technology, the analysis. So that has been the kind of interaction we have had with not only the brands, but also many suppliers.
Yeah, I was gonna say something along the same lines, actually. I think it's just it's an easy way for suppliers to fairly quickly get an idea, like really tangible results as to like what this really could mean. And it just is a great way. It's a starting point for us, to kind of put some meat to that conversation with the supplier and then inform some next steps. So instead of them going into it blind, like you can really very quickly get to some numbers that make a lot of sense.
Yeah, and as we like roll out the tool with our suppliers and show that this is just another thing that's available to them, like we'll be working to get that feedback, and then working with Ali and Cecilia and the folks here at the OAA to think about like further evolution of the CoLab. Like, do we need to make revisions to the tool? Like how are things in practice? What is the feedback we're hearing from our suppliers? So that's definitely kind of part of all of this.
Awesome. Thanks, Kim. And I think in our last minute, Ali, if you could answer the question, I think this is a great one to end with. Can you explain the tool for anyone who may not be familiar in the simplest terms for understanding? And Keelan, while Ali's doing that, if you wouldn't mind putting the links into the chat, that'd be great.
I don't know what is the simple. I would say it's a kind of a techno-economic analysis tool that you can put fairly few data points in the tool if you run the quick assessment and still get a fairly useful analysis and assessment of the electrification technologies that are applicable to textile facilities. Energy saving, CO2 reduction, cost, run different scenarios. So that's what the tool does basically. Then you don't need to go hire a consultant, pay a lot of money to do this. So you can do it in-house, get a very good idea. Of course, then from there, if you're an engineer, you run the analysis, you go to the manager, then you have a solid point to have the discussion. And then the next level will be kind of reaching out to some of the technology suppliers, discussing with them. They come do the assessment. You do investment grade analysis, which, by the way, we did with the textile facility in Thailand. So like we connected them with the heat pump manufacturer, the German one. They come did the assessment. Their analysis was fairly similar to what we had done actually for the plant, using something similar to the tool. So anyway, I went beyond, but simple techno-economic analysis helping textile engineer managers to assess the applicability of this technology for their plant.
Awesome.
Was it
I think
simple enough?
I think that's a great way to close things out. Thanks everyone for joining us today, and to all of our presenters and to all of our OA members that participated in the CoLab. And in the chat, you'll see more information to find the direct link to the tool that Cecilia was sharing today, and a link to another webinar in February that will be hosted in Asia time zones. So feel free to share those with supplier partners, and it will be the same presentation as today, just in a more preferable time zone. So thank you all for joining us today. The recording, slides, and all these links will be sent out in an email today. Thanks for joining us. Take care, everyone.
Thank you. Bye, everyone.